Hello, AP Prep 10th graders. Know that I'm sorry that I can't be there today, but as you can probably tell, my voice is a little bit off. But I am here for you to go through this stoichiometry practice problem warm-up. Know that mine looks slightly different. I need to type it up a little bit, but I think you've got pretty much the same thing right in front of you. So I'm going to go through this. The first thing I'll do is when nitrogen and hydrogen react, they form ammonia gas, which has the formula of NH3. If 56.0 grams of nitrogen are used up in the reaction, how many grams of ammonia will be produced? Write and balance the equation. So the very first thing we need to do is we need to write that equation. So I'm going to circle what we got, circle what we got, and circle what we got. So the first thing we have is, if you didn't already do this whenever you're practicing it, is you got nitrogen, and you got hydrogen, and you got ammonia gas. So if you're first thinking, sweet, you got it, back up. Nitrogen and hydrogen are both what you call a diatomic molecule, O2, F2, Br2, N2, all of those. You need to have two molecules. They can't just be by themselves. So that's something to remember that we've had in previous conversations. So if you have N2 and H2, so first thing I need to do, I'm going to balance it. So on the reactant side, I've got 2. On the product side, I've got 1. Again, if you get stuck doing this method is a great way to start mapping things out. And so you know kind of where a place to start is. So you're wondering, okay, where should I start? Should I start balancing by putting a 2 in front of here first? Or should I start to try to balance this one? Balance in a spot that is going to go from put the number from so you have a 2 and a 3. If you try to balance here, it's going to be weird. Odd numbers are always hard to balance. So start by balancing the 2 and the 1 is a good spot to start for sure. So you got 2. I'm going to change that to 2. But remember, and I know a lot of people are still struggling with this, so the 2 is not just for the N. The 2 in front of this is called a coefficient, as a reminder on that vocabulary. That 2 is going to apply to the H as well. But this whole molecule has 3 hydrogens. So that H, the 2 times 3, is going to be 2 times 3, it'll be 6. So right now, please notice we have our nitrogens are balanced, but our hydrogens are not balanced. So remembering, what number do I put in front of here in order to make this one be 6? What times 2 is 6? 3 times 2 is 6. So then we have now what we call a balanced equation. So we're just over 3 minutes in. You can see that you've got your equation is balanced. Now we need to go back through and reread our steps. And one thing that we need, and also to notice, is we also need to figure out what we need. So we've already established, so if you have 56.0 grams of nitrogen. I said 15, I know, excuse me. Fighting that cold is in my brain a little bit. 56.0 grams of nitrogen are used up in the reaction. How many grams of ammonia will be produced? So I'm underlining what we need to find. So we have ammonia and we have nitrogen. We need to get the molar mass of nitrogen and molar mass of ammonia if you're following those stoichiometry steps. Those stoichiometry steps will certainly help you. As a reminder, how we find the molar mass from the nitrogen, we need to get the atomic mass of the nitrogen on the periodic table, multiply it times 2. To get the molar mass of ammonia, we need to get the molar mass of nitrogen, the molar mass of hydrogen, multiply that times 3, and put that together to have the molar mass of ammonia. So I'm not going to put that in the calculator. I have that already calculated for us. So the molar mass of nitrogen is 28.01 grams per mole. And the molar mass of the ammonia is 17.03 grams per mole. So if I have 17.03 grams of ammonia, I have 1 mole of it. So then I'm ready to set up my problem. I need to reread. If 56.0 0 grams of nitrogen is used up in the reaction, how many grams of ammonia will be produced? So I'm going to start out with that 56.0 grams of nitrogen. Remembering that next step is 99% of the time going to be the molar mass. If we have the grams on the top, we got to have grams on the bottom. So we're going to go to 28.01 grams for every 1 mole of nitrogen. And again, that next step is going to be the mole ratio. If we have moles of nitrogen on the top, we need to have the moles of nitrogen on the bottom, which I get again from that balanced equation. There's an imaginary 1 right here. So then we've got a 1 mole of N2. And again, we're looking for ammonia, so we're going to need to get our 2 moles from our coefficients there. 2 moles of ammonia. But notice we're not looking for moles of ammonia, we're looking for grams of ammonia. So again, we need the molar mass. So if I have 1 mole of ammonia, I have 17.03 grams. Put a little equal sign right there. Move this down just a little hair. There we go. So we've got if I put this all in the calculator, if I 56 times 1 times 2 times 17.03 divided by 28.01, to start out with, I would end up with 19.07.36 divided by 28.01, which total would then equal 68.096 grams. Not putting this in the calculator, but if you entered this in the calculator, you should end up with something very similar. That would be, it extends, but if you want to go for practice with the extra credit on the test, you can round this to the number of sig figs. Remembering the number of sig figs is what is given to you in the problem. There are 3 significant figures, so our answer has to be in 3 significant figures. So this right here is 1, 2, 3, 4, 5 significant figures. We have 3. I need to round that to have 3. So I would round that to be 68.1 grams of ammonia for full credit. I need to put a box or a circle or a highlight of my answer. So that again is a little practice of the warm-up. Please do not hesitate to get in contact with me if you have further questions. You can also meet with me, hopefully, if I'm back on Thursday during lunch. Again, I'm hoping having a day of rest will make things feel significantly better. And you can also, if you'd like to send me an email, I can further give you other resources. Please, please, please use the resources on the website. They're there for you, and I'm there for you as much as I can be. Have a great day, and good luck with the practice. Check for understanding. Talk to you soon. Bye.